Could you expend a moment just celebrating the idea of symmetry in physics?
This is a really, really great question. So symmetry in physics, this is something that is extremely deep and has been very, very predictive and powerful over the last 100 years of physics. So this is a question that in my classes to undergraduates, I try and convey that a lot of physics is based on looking at a phenomena that you see, like an apple falling from a tree, and saying, how do I model the path that that's going to fall, right? Like, how do I write an equation that describes that? But once you start talking about symmetries, and these are basically rules for how you might change a space or an equation in ways that can leave it alone, once you start talking about symmetries, you actually have the power to ask, could the theory that I'm describing be any different? It allows you to ask questions about not just what you observe, but whether any theory that you write down could have arisen differently in nature. So the tangible, non-theological underpinning of that is that you can ask for a theory. If I write down this theory, like Einstein's theory of relativity, could it have been different? What is the freedom to change that theory at all? Could there have been any other theory of gravity that could have worked?
Wait, what does it have to do with our understanding of what the word symmetry means?
So the idea behind symmetries is that if I tell you about the rules for what I can do for a theory and leave it alone, that is equivalent to specifying the theory. So, for example, if you want to ask, how are the laws of physics impacted by the fact that if I do an experiment here, and then I move that experiment 5 feet to the left and do the same experiment, I should get the same answer, right? What is the implication of that for the laws of physics? It turns out that phenomena, that, the laws of physics shouldn't care whether your laboratory is here versus 5 feet to the left, that's very much linked to something like the conservation of momentum in classical physics. Or the fact that you should do an experiment today and get the same answer tomorrow is related to the idea that energy is conserved in classical physics.